This is the Unit 4A review. Let's review some triangle trigonometry. You learned that the ratio of sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If the radius on your circle is equal to 1 unit, then the opposite over the hypotenuse is just equal to y over 1, which is just y. Cosine, the adjacent over the hypotenuse, x over 1, or just x. And then tangent, opposite over adjacent, y over x. We have reciprocal identities, and we just reciprocate each of these values. So I have 1 over y, 1 over x, and if I flip this guy, I'm going to have x over y. Now, since this is a right triangle, we can do Pythagorean Theorem to find the hypotenuse. And so if x is equal to cosine theta, this is just cosine squared theta, the y is equal to sine theta. So again, with our Pythagorean theorem, this would be sine squared theta. Let me change that to a theta. And since this is the unit circle, it equals to 1 unit. To find other Pythagorean identities, we can divide the terms all by cosine and then by sine. So this is going to give you 1 plus sine over cosine, or y over x, is tangent squared theta, and 1 over cosine, well, that is the reciprocal of cosine, or secant squared theta. Okay, we're going to do the same thing this time with sine. So start with your original Pythagorean and divide everything by sine squared theta. Okay, so cosine over sine, that is going to give you cotangent squared theta. Sine over sine is 1, and 1 over sine is cosecant squared theta. And then you can manipulate these, move them across the equal sign to create many, many more. Okay, so our reciprocal identities, cosecant theta is equal to 1 over sine theta. Secant is equal to 1 over cosine. Cotangent's 1 over tangent theta. Quotient identities, this is tangent is equal to the sine theta over cosine theta, and cotangent is cosine over sine. And a little easy way I remember this, if it starts with a C, it's going to have a C in the numerator. Okay, we have some formulas to convert degrees to angles. Remember on our unit circle, we have 0, 90, 180, and then this is also 0 radians, pi over 2 radians, and then at 180 we have pi radians. These are equivalent. This is what we're going to use to convert. So convert the angle 180 to radians, well, that just equals pi. 30 degrees, if you don't remember your unit circle, you can multiply by pi over 180. Since we know that pi and 180 are equivalent, if we put the degrees in the denominator, that will cancel that sign. And so multiply across, we have 30 pi over 180. I can also cancel the 0, 3 over 18. And then I can further reduce that to pi. 3 goes into 18 6 times, so pi over 6. Okay, to convert from radians to degrees, 5 pi over 6. If I want pi to cancel this time, I'm going to put pi in the denominator. And so I can cancel the pi's. I can also reduce the 6 and the 180 just to make my life easier. 6 goes into 18 3 times, so that's going to be 30. And then 30 times 5 is 150 degrees. And that's how the rest of those work. Okay, in this triangle problem on the right, it says solve for the unknown sides and angles. Okay, so first thing I know is this guy is a 90 degree. And the three angles in a triangle add to 180. And so if I take 180 and then I subtract the sum of 90 and 74, so let's see, quick math here, 164, 180 minus 164, and that gives me that angle A is 16 degrees. Next, we need to find either A or C. So from one of the acute angles, and it doesn't matter, I can just, since I'm given angle of 74 degrees, opposite over adjacent to find side A. So I'll set up my ratio. Tangent of the angle is equal to 13 over A. And then we just need to manipulate this and isolate the A. So I'm going to multiply both sides by A. And then divide both sides by tangent 74 to isolate the A. All right, at this point, I got to go to Desmos to figure out what this answer. All right, so just pretend I went to Desmos and worked out 13 divided by tangent 74, and your A value is 3.728. So A is equal to 3.728. Okay, and then this is a right triangle, so I'm going to go straight to Pythagorean Theorem. And the sum of the squares of the sides, so 13 squared plus 3.728 squared is equal to C squared. And then again, by the magic of Desmos, we're going to see that this guy is going to be 13.524. Okay, let's go down to the unit circle. I just want to remind you, I don't know what you're going to need, but let's just go through the whole thing. Let's go through the degrees. We got 0 degrees here, 90 degrees straight up, 180, 270, and 360. Okay, the next thing I'm going to do is I'm going to cut each of these quadrants in half. Half of 90 is 45. So 45 right there. 90 plus 45 is going to give you 135. 135 plus 180 is 225. 270 plus 45 is 315. And now I've got all the 4's done. The next thing I want to do is divide it by 6. This angle here is a 30-degree angle, and so every 6, this is 1/6, the next one will give you 60 degrees. So I'm just going to be adding 30 every other, not almost every other, but every 30 degrees. So we have 30, 60, 90, 90 and 30 is 120, and 30 is 150, and 30 is 180, and 30 is what, 210, and 30 is 240, and then 270, and 270 and 30 is 300, and 330, and there's all the angles. Now the other pattern is that it jumps 30, 15, 15, 30 every quadrant. Add 30, add 15, add 15, add 30. And so you can keep going around and getting those values that way. The next thing, let's go ahead and get our radians since we've been working with that. So this is 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. And again, 30 degrees is a 1/6, so I'm just going to say this is pi over 6. Add a 6, so this is going to be 2 pi over 6, or reduce that, we get pi over 3. 3 pi over 6 would give you the pi over 2. 4 pi over 6 gives you 2 pi over 3 when reduced. 5 pi over 6. 6 pi over 6 is equivalent to pi. 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6 is going to be straight down. And then we have 10 pi over 6. That's going to be 5 pi over 3. We're just adding a 6 every time. And then 11 pi over 6. And then the last thing I need to do is fill in on the fourths. 45 is a fourth of 180. And so we're going to call, or of pi, I shouldn't say 180, but, or you know what I mean. I'm looking at the fourths. So this is 1/4. 2/4 would be straight up. We already got that. This angle at 135 is 3/4. And then we have 4/4. 5/4 is going to be straight down. 6/4 is equivalent to 3 pi over 2. 7/4. And we have all of the radian measures. Okay, so again, first count by sixth, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and so forth, and then go through and count by fourths, 1/4, 2/4, 3/4, 4/4, and all the way around. All right, and then to find the coordinates, I want you to Google the left-hand trick. That's just one easy way that we can remember what all of these coordinates are. So let's do that. Let's see. Well, first thing, this is our unit circle. So we know the radius is 1 unit. And so let me go around to all of the axis angles. So 1, 0 is at 0 radians, 0, 1, -1, 0, 0, -1. Okay, and then square root 3 over 2, 1/2. This angle, well, you're going to have the same values. If you remember, they go across, down. All of these angles will have the same coordinate. It just depends on the negative sign. So in this quadrant 2, the x value is going to be negative. In quadrant 3, both are negative. And in quadrant 4, the y value is negative. Okay, the next one, square root 2 over 2, square root 2 over 2. And it follows the same pattern, just go straight across. I think we had like a little bow tie or something when we did our unit circle project. All of these angles will have the same coordinate, just the negatives. Negative square root 2 over 2, square root 2 over 2. And in the last one that we need to fill out, 1/2 square root 3 over 2. And each of these guys will have the same. Just change the signs. Depending on the quadrant. Okay, and if I wanted to fill in this chart, remember sine is your y value. This is y value. Cosine is your x value. Tangent is the ratio of the y divided by the x. Cosecant is 1 over the y. Secant 1 over the x. And cotangent's the x over the y. And I can just run through the answers real quick. This is going to give you square root 2 over 2, -1, negative square root 3, and that is little quick math, negative square root 3 over 2 divided by 1/2. Keep, change, flip. So this is going to be negative square root 3 over 2 times 2 over 1. 2's cancel, and that's how we get the negative root 3. All right, cosecant 5 pi over 6 is going to give you 2. This is going to give you 2 roots 3 over 3. Again, if you were to what is this called? Rationalize the denominator, multiply top and bottom by the radical. That's going to give you the 2 root 3 over 3. And then the cotangent, hey, undefined, because of course 1 divided by 0 is undefined. Okay, so for these, I'm going to need a little bit more space. So I'm just going to kind of work number 1 down here, and hopefully you can follow along with me. So 2 cosine squared x minus cosine x minus 1. And we're looking for all the solutions between 0 and 2 pi. All right, so first thing I notice is that this is a squared term, and I have 3 terms. So this looks like a factorable trinomial to me. So I'm going to write it without the cosine and see if it's going to factor. So 2 numbers that multiply to get -2 and add to get -1. So that's going to be x minus 2, x plus 1. because the leading coefficient's other than 1, I'm going to divide both of the terms by that value, whatever this guy is. And so this is going to give me x minus 1, and bottoms up says bring the number into the front. Okay, so now we solve each of these. So this is going to give you, well, actually, let's go ahead and put cosine back in. So cosine x minus 1 equals 0, or 2 cosine x plus 1 equals 0. Add 1 here. So what angle has a cosine value of 1? And on the second factor, we subtract 1, divide by 2. What angle has an x value of -1/2? And I believe those would be, let's see, the x value of 1 is just going to be 0, or 2 pi. And an x value of -1/2, how about 2 pi over 3 and 4 pi over 3? Okay, so number 2, this is sine squared x minus 1 equals 0. And let's go ahead and solve for sine. Sine squared x is equal to 1, and then square root it. Just remember, you got a positive and a negative square root. So I'm looking for where y is equal to +1 or -1. And that is going to be pi over 2 is where it's positive, and 3 pi over 2 is where y value is negative. All right, let's see. In number 3, it's got 2 terms, and what I notice is that both of those terms have a sign in them. So I'm going to factor out a GCF. All right, so let's take the sign out. That's going to give you cosine x minus 1. So zero product property, we set each of these factors equal to 0, and we solve. And so the first factor is done. The second factor, we're looking for where cosine is equal to 1. So where is our y value equal to 0? And that's going to be at 0 and pi. That's where your y value is equal to 0. And where's your cosine is equal to 1? That's just going to be 0. So, okay, so we could also call it 2 pi because I believe the interval does say, yeah, equals to 2 pi. So, yep, definitely want to count that as well. And I don't need to write the 0 twice, but it's okay. Okay, let's see what the next one is. Number 4 is a factorable trinomial, so I'm not going to rework that. 5, yeah, so on 5 and 6, they're very similar to number 2. You're going to isolate the trig function and then take the square root and make sure you have the positive and the negative. So I'm going to leave those for you to do on your own. But please ask in tutorials if you need some help. Okay, so on the next section where it says simplify the trig expression. So I'm going to work a couple of these. Cotangent q, tangent q plus cotangent, cotangent q. So I guess the first thing I'm going to do is distribute. And I also recognize that cotangent and tangent are reciprocals, and when you multiply reciprocals, you get 1. So this is just going to be 1 plus cotangent squared q. Now this looks like a Pythagorean identity. So I'm going to go back up and see if I can figure out which Pythagorean identity. And actually, it is 1 plus cotangent squared q is equal to, this equals to cosecant squared theta, or cosecant squared q. And that one's done. Okay, let's try the next one. Sorry, I'm flipping through my notes. Number 2, I have 1 minus cosine squared q over 1 plus cosine q. Okay, so we could do this one a couple of different ways. I think I want to use difference of squares in my numerator because this will factor to 1 minus cosine squared q. Whoa, get rid of the squared. Cosine q, 1 plus cosine q. And that's all divided by 1 plus cosine q. And yeah, I can cancel that common factor. Y'all see that? there you go. That's as far as you can simplify this one. You can't really do anything else because it is not a squared, so that one's done. All right, let's see if there's any more. Let's try number 3. Secant. Dang, why do they have to use Q's? Okay, secant theta, cotangent theta minus cotangent theta cosine theta. I think I wrote that. Secant cotangent minus cotangent cosine. Couple of things that we could do. We could factor a GCF. I don't know if that would help us or not. Or we can rewrite in terms of sine and cosine. So I think I'm going to go with my second option. 1 over cosine. And sometimes you start working these and you go down a rabbit hole and you never figure out which way. You got to just erase and start over. So let's just try this. Secant's 1 over cosine. Cotangent is cosine. Got to write the right thing. Cosine over sine. Cotangent is cosine over sine. And cosine squared, cosine. So just times cosine. Okay, so let's see where this leads us. I can see I can cancel those guys. And I can multiply those guys. So I've got 1 over sine minus cosine squared over sine. This looks good because I have common denominator and I can put that all over sine. And I have 1 minus cosine. Oh, I went the right way. So this is sine squared, that's your Pythagorean, over sine, which is just sine when you cancel one of them. So we did go the right way, but sometimes you just don't know. Okay, let's see if there's any more that we want to go through. Number 5, immediately when I look at number 5, that's a Pythagorean identity. Sine squared plus cosine squared. This is just 1 over cosine squared t, which is just secant squared t, and that one's done. That's kind of an easy one. In number 4, I would probably, don't know. Let's see. Let's take a look at least one more, number 4. And maybe write in terms of sine and cosine, I guess. So let's see. Tangent is sine over cosine. Okay, I'm going to just take up all this space here. So tangent is sine over cosine plus 1. And this is over 1 over cosine. And what I can do is I can rewrite 1 as cosine over cosine. Because, well, cosine over cosine is equal to 1. And now in the numerator I have a common denominator, so I have sine plus cosine over cosine. And then I'll keep change flip, so multiply by the reciprocal of the denominator. And looks like the cosines are going to cancel. And so all you're left with is sine theta plus cosine theta. This does not equal 1 because they're not squared, and so that's it. In number 6, rewrite in terms of sine and cosine, distribute, and I'm going to let you work that one. Okay, find all 6 trig functions for the given information. Okay, let's do it. First thing I'm going to do is find the hypotenuse. So 12 squared plus 6 squared is big number squared. So 144 and 36 is 180. I'll call that c squared. So 180 is equal to c squared. And if I take the square root, do a little factor tree, I'll remember that guy. 2 and 90, 2 and 45, 5 and 9, 3 and 3. You have a date, you go out. So that's going to be 6 roots 5. 6 is on the outside, 5 is on the inside. Now you can go through sine of A, opposite of our hypotenuse. And you could rationalize. So I'd multiply by 5 over 5. 12 roots 5 over 6 times 5 is 30, and then you could reduce that. Cosine is adjacent over hypotenuse. This time I reduced first. I have no idea why. I just did. Rationalize, so root 5 over 5. Tangent, opposite over adjacent, so 12 over 6, which is 2. And then just reciprocate each of those, and you have the rest. On the last problem, cosine of A. Okay, so this is the adjacent and hypotenuse. So hand draw a triangle. I'm assuming it's in quadrant 1 because both of these values are positive, and I'll just call this guy A right here. So adjacent over hypotenuse, hey, that's a 3, 4, 5 right triangle. And, oh, well, if I want to find cosine A, how do I do that? How do I get A by itself? I want to undo cosine with inverse cosine. So if I inverse cosine on both sides, that's going to give me what A is. And I'll have to visit, oh, wait, it doesn't want me to find the angle. It wants to find the 6 trig functions. I'm sorry, let me go back and start over. But now you have that, and you can find your SOHCAHTOA. Sine, opposite over hypotenuse.